Hello guys, welcome back to the Rustic Wires channel, a channel for embedded Rust programming. I'm trying to create a common hardware abstraction layer. What I mean by common is like trying to create an abstraction layer which would be hardware agnostic, but ideally it's really hard to make any abstraction layer catering to all the needs to the current and future hardwares, but it's always better to try best to write the code to be hardware agnostic so that any change in hardware or anything in the layer below should not force the layer above or the application to change their code. Okay, so that's the motivation for this, and it has been a long time since my last video. So this is how it was, like the LED blink application code would call the gpio or library or gpio layer, and this is how it was. And I have recently introduced this digital IO layer in between. Okay, so first let's go and see how the current code is, or the previous code was. Then I will point out the problem with all those. Okay, so I have tagged the previous release V013. Excuse me. So if you see here, and inside the source, this is the binary file or the application binary. So it will uh, initialize the GPIO, and then the return of this GPIO, if you see, GPIO init would return the GPIO layer memory map address. So this tuple, so this is a tuple struct in Rust, and this is nothing but a raw pointer to this structure. So the problem with this layer is that first, yeah, so there's a clear, it's a modular code for sure, which is good, but what I was not happy about was that any change, so let's say that tomorrow if I want to switch to some other microcontroller or any other change in the hardware, then this structure, the GPIO memory map register structure, this is as per the FE310 manual, starting from address this, and every incremental by 4 bytes as the next register. So any change in the microcontroller would might force to change this APIs, or sometimes one of the feature, like let's say that pull up, internal pull up is not supported, so and so would force me to change the application code. Okay, and another thing is, if you see, these are all like being exposed to the this implementation specific code is exposed to the application binary. Okay, so that was a motivation, and I will show you how the current uh, code which I'm writing is in progress, and how this will mitigate this uh, changes that are needed when a hardware below changes. Okay, just to mitigate that. So let's go to the present code. So what I have done is, uh, yeah, we will see elaborately, but just to give a gist. created a structure, a digital IO pin. So in a platform, there can be multiple GPIO instance. So I have tracking the instance and a port name or port number and a GPIO pin number. So these are all these types are what is a custom types created in the code. Each one is like an U8. Then these methods are created on top of those struct. So in Rust programming or in Rust language, you can create these functions in two ways. One is you can make this as associated functions of a structure that is not necessarily of a structure of a module. And if the function takes a self, that means that it can be invoked as something like this, which we have. So once you get the instance, then you can call the method with the p dot so and so. Those are called methods, whereas the functions which are inside the module without taking the self just can be called with the namespace like this, and it can call. So this one are referred as associated functions. It's a common terminology, and these are all the uh, methods associated with a particular structure. Okay, so now let me go back here, and I have not finished implementing all the functions here. I have just started with that, and visibility we will come to this later. Okay, now let's jump into the code. So this is the digital IO layer which I am trying to create, so that application binary. So this layer would cater to all the hardware needs of the layer below. So mostly what are all the operations or what are all the settings you do on GPIO, all those should be uh, captured here. So when logic can be high, low, and let's say that in future, if there is an Z or a high impedance logic, then all you have to do is just add a new item here rather than changing any of this API signatures or method signatures. Okay, and so pull up, drive strength, and all that. Okay, and then this digital IO layer, if you see, there is no hardware specific address or anything, but what it does is there are many ways that you can call uh, a library or a module or a crate. So this is one way, which is like instead of use, I'm using the path reference. So what this says is like use the file fe310. So if you go to the directory here, there's a gpio.rs. Use this as a GPIO module. That's what the DAO says. So this digital IO library would in turn make calls to this hardware specific GPIO layer. And if you see, the another change I have made here is that it was a tuple struct before and invoked from the application binary. But now we don't need this because we don't need any of this details outside this file. So I just made that as a constant. Okay. And then from the GPIO library, so any function, for example, enable pin inlet, that means like so every GPIO pin has two can be read on the input side or also can be written on the output side. So this is like enable the input read. Okay. So this would pass the pin number to layer below or GPIO, and then those associated functions. So if you see here, these are all associated functions because these are not, this does not take any self parameter, and these are all part of this one file or this one module. Okay, and in this way, I feel that it's clean, but anybody who has much more experience on Rust, because I'm new to Rust, and if you think that there's a better way, please let me know on the comments. Okay, and so far it's good, and I'll just compile and run this code. So the main, I haven't finished all the implementing all the methods here, but it's it's a clean way, and I don't have to implement all that now because this is planned and this will grow, keeping in mind for all the future hardwares as well. Okay, let's just build now. So there are a lot of warnings because most of the functions are not used and not implemented yet. So it's a debug build. So I'm trying to load the binary into the board. I hope you can see the lost line as well. Host. So I'm just loading the built binary into the board, and you should be able to see the LED blinking on the board on this video. Okay, so that's about it. And the one thing I said, which I said that I would get back to that, is the visibility. So I mentioned that it's not good. There's no need to expose the memory mapped register address to binary layers above to the application binary. So there are many ways. So this link here covers the visibility in Rust programming language. Okay, there are this is the, what is that, full visibility to not only just within the module. It opens the interface and the data structures to anything, to the full crate and to any crates that's going to be linked or binded with this crate. Okay, and then the second one is what is interesting to me, which is like a public crate. That means that make it available or visible uh, only within the crate. So if you go to the code, this is what I would have done here. So this gpio, and since these are all part of the same crate, so these functions I just need to be visible to digital IO library, since they are all in the same crate, whereas the application binary is a separate crate and it wouldn't be visible out for that. Whenever I enhance this DAO layer, I'll publish the other video. And also in the meantime, I'm trying to create a common interface for serial port as well, instead of calling writing the code specific to the FE310 or if specific to FE310 hardware or the Hi-Fi 1 revision before. Okay, thank you, and please see if you like this kind of videos, then feel free to subscribe. Also, don't forget to watch the latest demonstration video on the RISC-V channel where I demonstrate the context switch or a simple demonstration of switching between two applications in RISC-V assembly. Okay, thank you.